to the scientific method.
Have you ever gone to a plant store and found a beautiful plant that you just had to purchase, so you purchase that plant and then find a nice home for your plant, and then a few weeks later your beloved plant is dead? At this point, you may be wondering why something like this happened. Let's use the scientific method to try to figure it out. The first step is to ask a question, or maybe a few questions.
Why did my plant die? What do plants need to survive? Am I incapable of keeping something alive? Am I destined for a lifetime of loneliness?
Calm down.
Let's narrow it down. It's best to try to focus on one or two testable questions.
Did I water it enough? See, I was going to, but I lost track of time.
Okay, no judgment here. Let's try to reword that into a testable question.
How much water does a rose bush need to survive?
Now that is a good question. Let's do a little research. What do plants need to survive? So according to the equation for photosynthesis, plants need CO2, water, and sunlight to function. Let's focus on water. Now what? Now it's time to create your hypothesis. Most of us learned that hypotheses need to be in an if-then-because statement. If you feel comfortable writing it this way, please continue to do so. However, you don't have to write it specifically that way. For example, this hypothesis is also acceptable. And crazily enough, you could even write out one this way, where you try to prove something incorrect in what we call a null hypothesis. There are some wrong ways to write a hypothesis, though. For example, this one is not appropriate, as it has a personal pronoun and some grammar errors. This one is also not a good example, as it has listed way too many variables to test in your experiment. What are variables? Well, let's identify the variables in our example. What do plants need to survive? You should always focus on testing one variable at a time. Let's identify our independent and dependent variables in this experiment. The independent variable is what you have control over. The dependent variable would be the outcome of your experiment. Remember, later on, while you're organizing your data, the dependent variable goes on the y-axis and the independent variable will go on the x-axis. The constants are the variables that you keep the same throughout your experiment. In this example, we would keep the CO2 levels, soil type, and sunlight amount the same for all test groups in our experiment. This will allow us to focus on only water's impact on plant growth. I do feel that I need to point out that constants are not the same thing as a control. A control group is what you use to compare to the experimental group. In our example, the control group would be the plant receiving no water. We know from experience that this is not healthy for the plant and allows us to compare it with other plants that we will be manipulating during our experiment. Now it's time for the next step, which is testing our hypothesis with an experiment. We have set up 4 separate pots with the same soil and the same amount of sunlight each day. We also made sure that all 4 groups started off with a young, healthy rose plant before we started manipulating their water amounts. Group A will receive no water and will act as our control group. Group B will receive a small amount of water each day, Group C will receive the average amount of water each day, and Group D will receive an above average amount of water each day. Now it's time for the next step in the scientific method, collecting data. While you're collecting your data, it is important to organize it in a way that will make sense to you for the next step of the scientific method, which is analyzing your data. Here you will look at the information you've collected and determine if your hypothesis was correct or incorrect. The best thing about the scientific method is that if you were wrong or you find data that's surprising, you can start over and test it again, or maybe test a different variable. If you are satisfied with your data analysis, the last step of the scientific method is to share your results. This step is super important in the field of science and medicine to ensure that it can be retested and confirmed by other scientists in the field. Even though our experiment wasn't groundbreaking science, it's still important to share your results because you might help someone else. So to recap, the scientific method is the way scientists in all fields work out important questions they may have for making observations. Even if it's just in my science class, I want you to be ready to ask questions, create appropriate hypotheses, experiment and collect data, analyze that data, and make conclusions and inferences to be ready to share your results with me and your peers. Hopefully by now you have a good understanding of the scientific method. Know that this tool can be used in a variety of situations, like maybe you want to know if listening to music helps you study for a test, or if eating spaghetti the night before a big game will help you feel more energized. So the next time you're faced with a question that requires you to have an answer with minimal bias or prejudice, use the scientific method to improve your results.